Hello, this is Dr. Lori. Welcome to this discussion on incidence and prevalence. These are two of the most important concepts that we'll be discussing throughout the quarter. Incidence, which is also known as risk of disease, and prevalence, which is sometimes called burden of disease. And so just based on those names, you would probably realize that that's a lot of the times that's what we're measuring when we're looking at things in public health. So let's go ahead and start by thinking about incidence. Now, if we're just thinking about the actual count of incidents, then we talk about that as incident cases. And you can see how, just based on pronunciation, that these can be kind of tongue-twisted and confused. So it could also be called incidents. So you can see how the confusion between incidents and incidents, because they really are pronounced exactly the same. But the take-home message is that incidence really has to do with new cases. It sometimes is called risk of disease. And if we were to apply that instead of to a count to a proportion, we would have the number of new cases divided by, and I'm going to put this in black, the population at risk. And then we continue to further identify that equation by saying at a particular location during a specified time period. That's time, T-I-M-E, sorry about that. And the new cases would be in that same location during that same time period. I can spell it. So here we have, for a proportion, we have of all of those who are at risk. Remember, for a proportion, the numerator needs to come from the denominator. The new cases come from the population at risk. If a person is not at risk of becoming one of those cases, then that does not belong, those people don't belong in the denominator for proportion. So new cases divided by population at risk for a specific location and time. Now, prevalence, on the other hand, has to do with prevalent cases. You could say prevalence, but I don't think we use that word as often. I'll put it here for completeness. The prevalent cases. And those really have to do with existing. And since we're thinking about the existing cases, think about a population. And if we say the prevalence of diabetes is a certain number, what that really helps us know is it helps us know how many services we need for that particular group of people with diabetes. It helps us know about maybe medications or hospital beds, or if we need to have educational training. And so this has been called the burden of disease. Like, what is the burden on society? That name has sort of fallen out of favor because to be a burden is a negative thing. But if you think of existing cases as the whole entire pool of all the ones that we currently have, then that will help you remember the difference between prevalent cases and incident cases. Now, if we're thinking about that in terms of a proportion, then here we have our existing cases, and that's divided by, and this is a different number, or different denominator, sorry, the total population. Again, for a specific location and time. Prevalence is usually expressed as point prevalence, so on January 1st of a specific year. It can be period prevalence, but we'll stick right now with point prevalence because it's more common. And the existing cases would be in the same location and at that same defined time. So existing cases over the total population versus new cases divided by only the population at risk. And so our denominators are different and our numerators are different. The second thing that I'd like to show you is how we have kind of conceptually there's a relationship between prevalence and incidence. So if we were to draw that as an equation, prevalence is proportionate to incidence times duration. And I want you to think of an analogy that I've seen in a variety of different places. I want you to think of a bathtub. And this bathtub has a faucet, a spigot. It has water dripping into the faucet, or sorry, into the tub. And here we have our current water level. Now every tub has a little drain, and so the water can go out. And if the water sits there long enough, I don't know if you've noticed this for kind of pools of water, the water can also evaporate. And so there are a couple of ways that water can get out of this pool. And there's one way that the water gets into the pool. This whole idea of prevalence being proportionate to incidence and dense duration makes the most sense when the whole system is in kind of a steady state. It's not like the faucet got suddenly turned on faster than it used to be. So we'll erase all those extra arrows. And it's not like now all of a sudden the tub is stopped up when it didn't used to be. So if you're in kind of a steady state, then this equation works the very best. As soon as you change any of those parameters, then it's not going to be as descriptive of what's going on. But think about the prevalence here as the water level, and the incidence as the new, remember this is new water coming into the tub. Prevalence is existing water that's already in the tub, and how long it stays in the tub is determined by how much water can escape through the drain. So if you put a stopper in, or if your stopper is working properly, then less water is going to get out. And here we have our water that's evaporating. So if you have maybe a climate controlled room, then less of the water is going to evaporate. And we think of the water going down the drain as death, and the water evaporating as people recovering or getting cured from the disease. So if people are getting cured from the disease pretty quickly, then the prevalence of that is going to still be pretty low because the duration is short. So an example of something that cures pretty quickly is the common cold. People will get a cold. They generally have the worst part of it for about 3 days, and then they feel kind of sort of halfway miserable for maybe another week, and then maybe they're completely better in 10 days. Now, in the meantime, they gave that to another one of their coworkers, so then there's a new incident case that's coming down into the pool. But then they're going to be cured pretty quickly. So at any given time, there usually are not very many prevalent cases of the common cold. Sometimes things can go around either in a classroom or in a workplace, and there's more prevalence, but then pretty soon it's gone. On the other hand, if you have the kinds of diseases like cancer or some other chronic diseases, as soon as a person is a new case, an incident case, they're added to the pool, but if it's not possible to be cured of that disease, then they stay a prevalent case for the rest of their life until they die. So, prevalent cases aren't necessarily bad, though, because if you think about death, if that's your only option, then having a lot of people who are living with a disease and managing it quite well, that means that this water level is going to be going up and up and up. The tub is going to be getting fuller and fuller because there's not the option of death. Maybe we're doing a better job at managing diseases and preventing complications and that kind of thing, so people are living longer with that. So if either if a disease lasts for a long time, then the prevalence can go up, or if the incidence is higher in a specific population, then the prevalence can go up. Likewise, if the duration is short or the incidence is short, then the prevalence of that particular disease is also going to be shorter. The number of people who have that disease at any given time. So keep that relationship in mind. It's a very helpful relationship to think of, the relationship between incidence and prevalence, and also keep track of some of the terminology that we've covered in this lesson. Thank you for joining me.